to ACI Learning's Leadership Series. My name is Wes Bryan. I'm an edutainer here at ACI Learning, and today we're discussing how leaders can make sure that their clients' data is protected in the cloud. We're going to be discussing some of the can make sure your organization's security is up to date. And here to help us out with that is Ben Finke, CTO and co-founder of OnDefend. Well, welcome, Ben. Thank you for joining us today. How's everything going?
Thanks, Wes. It's great. Really happy to be here with you today. Looking forward to discussing cloud security.
All right. We appreciate having you. You know, organizations are increasingly moving away from that traditional rack and stack behind us, the on-prem deployments and data protection. And, we're shifting into the cloud today. Let's begin with that. What does it mean for an organization that has done that traditional on-prem implementation where they're maintaining everything and we're deciding that we're going to do, and maybe not in the actual, I would say, activities of a lift and shift, but we're thinking about moving into the cloud. What does that mean for an organization today?
Yeah, that's a great question. That is one we get a lot. Let me first say that I think there are several kinds of clouds out there. When people say generically, though, that we're moving to the cloud, they generally mean the public cloud. And that has a few kind of specific things about it. Basically, in the public cloud, everything is always accessible from the internet. So you get to configure whether or not it is, right? But it's all internet facing. You have this sense of sort of elasticity in terms of your deployment, so you can kind of like surge up or surge back down based on usage. In fact, I mean, the number one draw for sure of the cloud, in addition to, I guess, maybe the speed of being able to deploy new systems, is the idea that, in a traditional on-prem system or setup, you've got so many servers to handle your peak capacity demands. Right. And then when you're off peak, you don't get to give some of those servers back. Right. That's kind of the allure of public cloud computing, is when that off peak time hits, you shrink back down, and supposedly speaking, your bill shrinks. I think the most companies, once they get in there, find that the bill tends to only go up. And that is one of the tricks of managing a true cloud deployment.
Most definitely.
But
Go ahead.
Go ahead.
Yeah, absolutely.
The biggest thing that we see there, though, is that the fact that a lot of times companies will there's multiple ways to get into the cloud, right? You can take existing stuff that runs now and just reinstall it in the cloud, or you can really sort of take the opportunity to redesign those things to handle some of what the cloud is better at. So in cloud, we have everything from what's called infrastructure as a service, where like the operating systems and things are still yours to manage, just like they would be on-prem. But then you kind of move up into more of platform as a service, and then truly software as a service, where the cloud provider takes care of more of the underlying things for you, and you're just configuring an application. And that can be sometimes where the savings can really show up. But that's really the thing, is there are so many different ways to move into the cloud. So I think once you've identified the thing that will work for whatever applications that is, then we can start talking about how you would secure it.
Oh, most definitely. You've talked about some of the advantages already, in your opening statement. One of the things I know is that traditionally, we've had a very monolithic approach on how we build our applications. And one of the things we can do is to kind of steer away from that, decouple all of these components and, again, make them more cloud native, and be agile and be able to move in a very fast-paced environment and adapt to new technology. Now, I know that's some of the advantages of it, but what are some of the other advantages that maybe you see?
Well, I think some of the other big advantages are, one of the major problems that we have as an on-prem situation is configuration and patch management, right? It can be difficult to do this at scale across a lot of these tools. One of the advantages, if you follow a lot of in the cloud, sort of everything becomes code, right? This infrastructure is code thing, where you can create, deploy, and bring stuff down without having to go through the manual steps of doing it. So the idea is that you can manage sort of that configuration a little bit tighter. And it's also, especially if you take advantage of more of like the platform as a service and software as a service, the higher level things, you kind of turn over the patch management to that cloud vendor, and that could be very beneficial, because now you don't have teams worrying about that. You don't worry about whether we're up to date with the current patches. That's the service provider, the cloud service provider's job, right? And so I think that's some of it. I think the other thing too is that kind of everybody's going there, and it's the idea of you sort of get this built-in disaster recovery business continuity thing. And I think that's one of the allures too, is like, hey, listen, like we are just kind of always operating in a multi-availability zone, or whatever the right language is for your cloud provider environment, so that we don't really have to worry about doing DR drills anymore, because we're always DR'd. As you can imagine, that comes with varying levels of success too. But it is true that if you follow a good cloud deployment guide and a good model, you can have a lot of resiliency, even if you lose that service provider's, uh, an availability zone, or a data center or something. Your app can survive, as they say.
Most definitely, and it's nice to see that you have guidance too, and some of those BPAs, those best practice analyzers that we've used in the past, now become like the best
Yeah.
recommendations and stuff. It's nice to follow now. I know one of the challenges as our digital footprint becomes so vast. If we are controlling everything on-prem, it has its own challenges, and it's not just a walk in the park. But as we start to become more dispersed in an environment so easily, like the cloud, our data can be sitting in, let's say Azure for whatever it could be, or wherever it could be, a region on the East Coast, and that data could go into a DR situation, and then all of a sudden be under California regulations and in California. What are some of the challenges when it comes to the fact that yes, we do have very agile, we can deploy very fast, very scalable, very large, but it seems that it comes with a certain complexity as well when it comes to protecting your client's information and data.
It sure does. Well, and not only do we have those troubles inside the continent of the United States, where we have states with differing levels of those, but of course the EU sort of famously has much more stringent consumer privacy laws than the United States does, right? And so if you're going to be able to support those types of constraints, you're probably going to need to build a data protection strategy that's uniform to the most extreme, right? So that you can be covered. So if you find out that some data you have on some EU citizens happens to reside in an availability zone in California, kind of doesn't matter to the EU, right? It's the data about the EU citizen that matters. You'll also have some other situations, and this we've done this directly ourselves, where you'll work with customers who have very specific, or their countries have very specific data sovereignty laws, meaning that the data has to physically reside on a disk someplace in either that country or a very small list of acceptable host countries, right? And so in that case, having a cloud provider that has multiple data centers and those things can really simplify that for you, right? Because if you're already familiar with deploying your application into an Azure or AWS or Google Cloud, and then you just know, like, I just need to do it in this specific data center for my existing service provider, that can be very simplified, and make it pretty fast for you to be able to respond to and manage those things. But you're right, data management like that is really tough, because it's not so much that the data gets copied. The data, the best way I've had it explained to me was when data gets moved into some of those things, it sort of breaks like glass and goes like shards everywhere. So it's very hard to clean up once the data gets in there. And so you have to sort of put some very helpful controls before the data gets into the system, and then assume that these parts of these connected systems all require the same data controls that you're going to put on whatever your main database or data lake or whatever fancy term you've decided to use for where that data gets stored, right? That all has to go in there.
Most definitely.
But yeah, I think that is probably when we talk about being able to meet those data sovereignty laws. I mean, the good news is that the cloud providers still do a pretty good job of letting you know and be in control of which zone these things are going into. But I would agree with you that it's not hard for a well-meaning engineer to come in and turn on a new zone that you didn't intend to use right away.
For sure, yeah, and we know that it can happen fast, because at the end of the day, it's on demand and a click of a button. So we definitely have to be diligent. When we look at the architectures, and maybe I rephrase this, the deployment types of cloud, whether it's all in public, whether it's a private cloud, or let's say a hybrid. I know there are other ones like community, but these three major ones, and I know hybrid forms a lot of the bulk of deployments today in the cloud. What architectures benefit from cloud-based data protection?
So I think if we're going to talk about like architecture strategy, the ones that benefit the most, well, the types of apps that benefit most from the cloud are sort of like decoupled, sort of like functionally focused apps. And this is one of the reasons that we see containers and Kubernetes and Docker and all these things become the rage. The idea of you decompose an app into its kind of core services, and then it has its own connections to databases. I mean, that really does take advantage of the idea of the cloud being sort of like a decoupled group of things that allow you to generate an entire app. I mean, that format is very useful. Now, we've worked with a number of customers who have taken an on-prem, what they call a monolithic app, so like one big application that has one big database, and then decompose that into multiple small sort of services, and then reconstructed that in the cloud like that. And that tends to be highly successful in the cloud, just because if you think about the different components we're going to put in here, the customer interacts with sort of like your edge, which for different clouds can be different types of things, whether it's a load balancer or a content delivery service. And then behind that, you can kind of load balance the connections coming in, the logic apps that have to run, and then the connections that they need to make to other data sources, right? You can kind of mediate all that. And by being able to spread that out, you can kind of move this service over to this cloud or to this data center, these things. And so that one tends to be very successful. If you take the lift and shift idea, we have a monolithic app with a big database, we're going to move that wholesale into the cloud. So we're just going to run it in there instead of running it on our own. That tends to not be as easy to move around and have like sort of self-DRing and self-data protecting, right? Like you can do on some of these other ones. That idea of the containers, when you have each container having access to sort of its own databases, also means you can sort of phase in, like let's say you wanted to put on sort of an additional layer of encryption at rest for data, right? So a lot of on-prem deployments of an application, the database itself takes care of when the data comes in, it gets written into the database tables, and then as it gets written to disk, it gets encrypted. So the app doesn't know anything about the encryption, doesn't need to, because the database engine takes care of all that for it. But you may want to have a separate set of encryption where a database admin who can look at these tables shouldn't see the data, right? And then the app knows how to decrypt the data once it comes back. And so that's easier to phase in on different, like, multiple different small databases as opposed to one big, large database where you've kind of got to do it all in one fell swoop, right? And sync those changes up.
Yeah.
Did that answer your question?
Yeah, it sure did.
Yeah.
Yeah, definitely. And it used to be we would have all of those pieces maybe on one or two servers. Now I'm oversimplifying that. I'm saying from a diagrammatic standpoint, you have your web front end, you have your business logic, typically middleware that's in the middle, and then you have your database on the back end. And sometimes that could be all into a single server providing that app. Well, what if you need to bring that functionality down and you need to upgrade those components? I could see where that decoupling, because if those components work together holistically, but aren't aware of each other, then updating individual pieces can make it a lot easier. Question now, we know that there are definitely some advantages of going to the cloud, but let me go ahead and put my Debbie Downer hat on here. And what are some of the, maybe the downfalls, right? Maybe disadvantages that you can think of moving to the cloud?
Sure. So this may not be as big of a deal anymore. It certainly was when cloud started, and I think organizations are still figuring it out. But when public cloud became a real option and companies started looking at it, I think the very first thing they realized was that from a security perspective, almost all of the tools we're used to using to manage and protect enterprises in an on-prem state basically don't exist anymore in a cloud environment, right? If you think about a traditional on-prem, like how we're going to defend the enterprise, there's a lot of network appliances, whether it's firewalls or intrusion prevention systems or data loss prevention or all these other things that are physically connected, like the network literally flows through them, so nothing can get in or get out that isn't mediated by these devices. Well, that totally leaves, like, you can't ask Amazon to hey, could we install a firewall at your internet connection, right? Not a thing you can do. And if you think about how we protect the endpoints themselves where the processing happens, most servers and things, we would deploy some kind of an antivirus agent or an EDR, an endpoint detection and response tool, something like that. Can't do that either. I mean, you still could if you built a compute instances where you're like literally getting the operating system and managing it from there. But to really take advantage of the speed and functionality of a cloud, you want to have it be more of an application level deployment anyways. And so, yeah, you no longer get those. And so it became a very big thing where a lot of security professionals who were very good at defending and sort of the on-prem castle moat strategy area, or I guess we'll say that they were really good at operating those tools, suddenly found out that none of those skills really mattered anymore in a cloud deployment, right? It's really more of a thing where you have to be able to manage the configuration of things, right? Which means you have to sort of understand how developers are coding those things. So languages like JSON and YAML, where they're building the configurations for these things. And weird things like identity becomes boundaries, right? Networks while you can still do some networking stuff in there, for the most part, networking is not a boundary or security boundary anymore. It's all about the identity, right? So you build permissions for this service account to do this thing over here. And so that really has been, I would say, the thing that most companies are still struggling with today when they talk about securing a cloud environment is that their security team has been very good at their on-prem stuff. Just those skills did not translate immediately. So those teams really had to go staff up with some other skill sets, right? Of folks who knew how to do really sort of almost developer type work, right? Which for a long time, there were folks in security who had no problem writing scripts and doing things, and there were folks who didn't want to do that. And I think that's going to be a necessary skill for security teams moving forward to be operable in a cloud world.
Yeah, definitely, especially with software-defined networking kind of revolutionizing and reinventing the way we think of programmatically controlling our networks versus hands-on in the server closet looking for a blinking light that maybe is red, for sure. So,
Right.
here
Right.
comes probably, one of the most expensive questions. What are some of the best practices for client data protection if we're thinking about that cloud mindset today?
Yeah, yeah, that's a great question. Well, so first of all, a best practice from our perspective when we consult with customers is that it is very difficult to understand the layout of a cloud environment, like a proposed architecture, if you're on the outside. So we definitely recommend that you have the security team sort of get embedded with a lot of groups will do full what they call DevOps, with the idea of like you're kind of putting together the developer and the operations team and being able to do some of this agile deployment. A lot of that really relies on the idea of like the speed that you get with the sort of the cloud deployment methodology. So the idea is like you embed a security person in there, and then that way they can sort of keep an eye on what's happening, so that when a proposal comes up that they're going to put, for example, a database, and it will be publicly accessible, they can raise their hand and say, that's a really bad idea. How about we do this instead? That way you don't have to go find out later. It's a funny situation that most of the so-called cloud breaches that we see where data is stolen doesn't come because the clouds are insecure or because the applications are necessarily vulnerable. It comes because the data was put in a S3 bucket, which is just a storage object in AWS, or a blob storage container. These things have great names, don't they? In Azure, that just allows anonymous, unauthenticated access. Same thing with we'll find out that there are databases and Redis servers and other things that are data services that are put on the internet with no restrictions, and they frequently have the default username password. Still working on those, which is almost always the admin account, right? So a lot of times those are kind of the problems that we see there. So from a best practice perspective, it's really good to have a security person kind of embedded with the team that's developing the architecture anyways, so that they can understand and be there the whole time that they're going through. Another thing that's really important when we get in there, a lot of these cloud service providers have great tools that will allow you to specify actions that are allowed or aren't allowed, right? Or conditions of things. But that can be very difficult when you're first experimenting with using that cloud. I'll give you an example. We were working with a customer, a software as a service vendor, who was migrating themselves to the cloud, and they were doing the thing where they were going from a monolithic app to more of a service-based architecture in the cloud. And the security team saw that there was a setting that basically said, don't ever allow an encryption key to be built that never expires. Like any encryption key we have should absolutely expire. They have all these controls that say, refresh, encryption keys after so long. So they put some rules in there that basically said, if you try to create an encryption key that never expires, like block that action and fail that build. And they thought that would be very clear and obvious to the developers. And what actually happened was developers would be going and trying to build a very basic something like an application service or something that was a very basic part of what they were trying to do in that cloud situation. And part of that in the background goes to create an encryption key. And if you don't specify, it creates an encryption key that never expires. So every time they would go to create a very basic element of what their plan was to go to the cloud, it would fail, but wouldn't tell them why. And they spent weeks in this deadlock state where none of the developers could build anything. They had all these calls and stuff going on. They finally got some support from the vendor pulled in, and they were able to identify it was this policy that was prevented all that stuff from happening. So I think it's important to, when you're going in and you're going to phase in those controls, that they should be sort of a monitor and alert at first, and then you can build them into blocking as you go, right? And then as you kind of embed your security practice along into the architecture. A lot of that stuff will just kind of flow into it. So you can say, like, we're going to start phasing this thing in. The other thing that I'll say from a best practice is that everything in a cloud environment generates logs and telemetry. And it's really important from the outset to start having a strategy for how you're going to collect those, and how security and operations teams are going to be able to make that data visible so that you can answer business type questions like which user performed this action in the application, right? It's amazing. A lot of times we'll go places and they won't have an answer to like basic things about like which administrator, generated or created this virtual machine, and they will have no data on that kind of a thing, right? So things that you would want to know. It's really important from the outset to make sure that we have a plan how we're going to collect these things, where we're going to put them, how we're going to review them, those sorts of things, and understand, like, is this usable data? Is it not? When do we turn on more for debugging and troubleshooting? That sort of thing.
All right, Ben, thank you so much for joining us, and thank you to the viewer for watching us here at ACI Learning's Leadership Series.